Okay, so welcome everyone to AP Physics. Let me check it out. It's okay. So welcome everyone to AP Physics, your own channel. So today, yes, it is. So welcome to your own channel that is AP Physics. So today we'll be studying. We'll start it from the chapter number one in the series of AP Physics. So this course completely will is. I mean, you can use this course for any of your exams. It works. Okay, so it's completely a basic course for any interested physics student. So let's start it. So this is our first chapter number. Okay, so I'll suggest you that you can also take the notes live. Okay, if you have any comments, please give a comment on the YouTube, or you can also give a comment on the live. There is a section near the video. Okay, so I'll give my details in the description for the next live session. If there are any technical issues, please do not forget to give a comment. Okay. And for connections, please look after the video in the description link. Basic mathematics. Okay. So why it's required for us to understand this topic? I mean, what's the important? You must understand this first. Right? So basically, if I say, if understand this basic maths, I mean, without the maths, you'll be not able to understand, how the physics has been formulated. Okay, so it all starts from the maths. So now let us start it. So in the today's series, basically, we'll be going through these three topics. So at first, we'll be studying basic mathematics, basic trigonometry. Okay. 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 After this, we'll be understanding that differentiation. Okay, I will be slow. No worries. What are the comments you are giving on the Zoom session or on the YouTube? It's coming towards me. Okay, I mean it's with me. So any of the queries will be resolved immediately, instantaneously in the live session. So at last, it's basic integration. If you want to join me freely in the live session on the Zoom, please look in the description after the session. Okay. So from the next live session, you can join me directly via Zoom. It's not required on the YouTube. But if you comment on the YouTube, it appears. So our goal will be that in this chapter number one, we will be completing basic trigonometry, differentiation, and basic integration. Very basic it is. Okay. So please note it down. See, for the basic physics, I mean, for the basic mathematics, this is just required for the physics. So we'll not be studying a lot of trigonometry things. Okay. A little bit the formulas or fixed ranges of the formulas. You just have to remember to solve the further numericals. I mean, after this, we'll be going towards the unity dimensions, then laws of motion and all those things. Okay. Can you point out any of the error here? Please send me on the Zoom session. Among these values, is there any error in this? Please check it out. Yes, you're right. So one of the student have clicked, it's not defined. Yes, because see, we know this thing. Tan is what? Tan function is what? It's sine theta upon cos theta. So it's very easy. We'll tell sine 90 goes 1 and 1 upon 0, this goes infinity. So basically this is not defined, okay? So you can write it down as not defined. Okay. See, these are some of the basic trigonometric values you must always remember. Okay. Now, after this, there is a special triangle which always appears when you are solving basic, especially when physics numericals. Okay. So what's this special triangle is? Let's check it out. So the special triangle is having the angles 37 degree, 53 degree, and of course right angle triangle 90. So there is a tricky way to remember this triangle. What's the way is? So it's something like this. The longest side is 5 and this is 3. So you can remember it as 53 degree. Okay. Other, of course, this one is, since it's a right angle triangle, so it is 90 degree. This is 53. This is what? 37 degree. Okay. And this is 5, this is 3. So why hypotenuse? I mean, you have the Pythagoras theorem. This will be what? 4. So this is among one of the special triangle. You must always remember. So from this, we can find any of the values, we can find, it's like 53. If you wanted to find sine 53 degree, what is it? Sine 53 means perpendicular upon hypotenuse. So perpendicular is what? This 4 upon 5. Cos 37, if you need to find, it's something as base upon hypotenuse. So it's 4 upon 5. Tan 53, suppose a random selection. A random selection, if I say tan 53, it goes for what? It goes tan 53 means like perpendicular upon base. So this is something as 4 by 3. I hope you are able to understand the things. Okay. So please note it down. This is a special triangle which is always required in the further sessions. I mean, you'll majorly find the numericals asked on these trigonometric angles. Initial one was fine, but this is most important. And we already know what sine, cos, and tan. Okay. Reverse also, it's cosec, it's sec, and this is what? Cot. Very easy. Please note it down. I hope you have noted it. Okay. So after this, any queries? Okay, no. Now we'll see after some standard values, we'll understand. Okay. What is this radian thing? Any guesses? You can text in the chat box. Okay. See, for this, you must understand the relation between theta, arc, and radius. It's very easy. So suppose, suppose there's it's an ant. Let's assume it's an ant. Okay, so this is an ant. and the ant is traveling shoo, like this. Interesting. It's not interesting, by the way. So it's traveling like this, and suppose this is an arc. I mean, the ant has traveled the path length which is equals to L. You know, this is an arc. So arc is a part of a circle, isn't it? So what I'll be doing is this. I'll be connecting this with this point here. Suppose this is a circle's center whose part is this arc. So I'll suppose that theta transferred is this and r is the radius of that circle. So we have a special relation we must always remember. So we say theta is equals to arc, which is the ln upon radius. You must always remember this. It's also important while doing, integration, or sometimes we need to generate some center of mass and all those things. We'll study in the future sessions in the next classes. It's very helpful. Little bit conversions. We will study in the unit dimension chapter that there is something which is known as, we have supplementary quantities. We have, there's a physical word and there are the physical quantities. So we differentiate these quantities into basically, different. There is a way through which we can understand all this unit dimension thing. So there are basically different quantities. We have supplementary quantities. We have other basic quantities. So among the supplementary, you will understand in the next session when the chapter unit dimension will start that this basically radian and all those things, radians and steradians and all of them. So now we'll understand a little bit conversion, radians, degree. So 2 pi, that's 360 degree. Pi, it's 180 degree. Pi by 2, it's 90 degree. Pi by 4, it's 45 degree. So if you are just able to remember this 2 pi, then it works. Okay? Because the rest of the values we can easily find it out. Please note it down. After this, we'll see identities. Okay. So now the thing which I'm going to write here, you must always, just learn it by heart. So we'll say identity is first, and then you need to remember double angle formula. So this basic three identities, you must always remember this. I'll be also providing you the PDF notes in the description link. Okay, so it may take time to activate that link, but it will be provided. The notes will not be the screenshots basically, it will be a well written PDF handwritten notes. Okay, digital notes basically. So So these are the three identities you must always remember. Sine squared theta plus cos squared theta 1, sec squared theta minus tan squared theta 1, cos squared theta minus cot squared theta is equals to also what? 1. Now we'll see double angle formulas. See, these are always used. The content which is provided to you is the most important and the filtered content. Okay. So please be very much alert while writing all the things. So double angle formula, among these three formulas, all are important. That's fine. You'll find while solving the questions that the physics numericals, it's useful. But this is the most important. You will say, what's the importance in this? And then, when you counter yourself with the majority of the problems in physics, this is this you'll counter yourself many times. Okay, please note it down. So sine 2 theta 2 sine theta cos theta. Cos 2 theta is cos square theta minus sine square theta. This I'll be using in this. So there will be a manipulation in this. So after the manipulation, you'll get this answer. Tan 2 theta is again very easy. It's 2 tan theta, 1 minus tan square theta. Okay, very nice, students. Any queries, please give a comment in the chat box. Okay, so after these identities and double angle formulas, we'll see addition formulas for you. Now let's start with addition formulas. The last two formulas, I want you to predict. Anyone? Okay, follow. So this is cos A, cos B. When C comes, it overtakes everything. When C comes, it overtakes everything. This is a trick, remember it. So we'll say it will overtake this and this. So we'll get cos A, cos B minus C. Overtakes something negative. So minus authority by force, something negative. And this one is okay. Please note it down. Okay, my dear students, now I'm erasing this. If you're having any query, or if you want the special notes, from you suppose you want the notes, handwritten notes from, say, movement of inertia and the rotational mechanics. So please give a comment in YouTube dialog box, or after the description, after this session, from the description, you can, you can contact me for live Zoom sessions. Okay. So now we are having two more addition formulas. These are okay. So it's very easy. You just have to remember tan is simple. It will not overtake. So tan A plus B, same series. 1 minus of this tan A into 10. So at first plus, then multiply it. So they are added and then they are joined. You can think like this. They are added and then they are what? They are joined. Okay. So after this, if you see tan A minus B. So this is also the same. If it's minus, they will be subtracted and then again they are joined. But always remember that the sign is changed in the denominator. Okay. The sign is always changed in the denominator. Remember this. So here also it's changed, change. Okay. So we have studied a lot of mechanical things. So now we'll be solving numericals. Okay. So here is your first question. So you have two values, sine 15 degree and tan 75 degree. Please solve it. Think that what will be used, whether addition formulas will be used or identities, double angle formulas will be used, blah, blah, blah. Okay, so please solve it. Okay, so your time is up. Now I'll see. We know this thing 15 degree. 15 degree. Just check it out that whose, so suppose let us take two angles and add them and subtract them. Somehow via the combination will this come 15 degree. Let us check it out. 15 degree, so this will be something as, I'll say 45 degree minus 30 degree. This gives me 15 degree, isn't it? And if we say about the 75 degree, I'll say 45 plus 30 degree. This gives me 75 degree. Yes? True. So we'll say sine 45 minus 30 and tan of 45 plus 30. I mean, I'm not writing it since it's the same, it's a degree. So, okay. So these are addition formulas, isn't it? So I'll say sine A minus B. So it's sine A cos B minus goes what? It's same here. In the sine function, in the sine addition formulas, these things are same. So it's minus goes. It's simple as minus same. And reverse the angle sine 30 degree and cos 45. And this is tan 45 degree. This is tan 45. So we know this is as what, tan 45 plus tan 30 degree. And this is 1 minus tan 45 degree and tan 30 degree. So please solve it. You get the answer. We know sin 45 is 1 by root 2. Cos 30. Cos 30 is root 3 by 2. Okay. This is half. This is again something as 1 by root 2. So when you solve this, this is root 3 by 2 root 2. This is 1 upon 2 root 2. This is something as root 3 minus 1 upon 2 root 2. Okay. If you solve this, you'll get an answer as tan 45 is 1 by root 2 plus it's 1 by root 3. It's again 1 minus 1 by root 2, 1 by root 3. So from here you get an answer something as root 3 plus root 2 upon this is root 6 minus 1. You can take the conjugate and solve it. Okay, very easy questions. Let's move next. So let me tell you, there is an error here. Let me check it out. Root 3, 2. This gives you, yeah, it's fine. What is in this? It's 1 by root 3. What is in this? Oh, I made a mistake here. It's 1045. It's 1 here. Okay. So this is again an issue. You erase this. So I'll say this is 1. I mean, it's 2, 3 plus 1. This is 1. It's very, I mean, sine 45 degree. I apologize for this. This is 1 by root 2 and this is also 1 by root 2. So we get tan 45 degree as what? 1. Okay. So this is root 3 minus 8 is not even. Okay. So now we'll be directly starting with the differentiation. Okay. If you want to practice more numericals, which is basically based on this live present session, I'll be providing the link in the description. I mean, there will be a Google Drive link. You can click it, press it, and then you'll be directly find yourself on some page from where you can download the practice sheets. Okay. So after this trigonometry thing, our second goal was will be, I told you, we'll study differentiation. Okay. So let's start with differentiation. Now, what is this differentiation? Any guesses? Any guesses? What is this differentiation thing? Yes. Okay, so look, this is different. So, when we are studying any of the terms, suppose we say our subject that is physics. Physics is made of 2 words. We see in the Latin, we see in the Greek, and then we make the combination and we understand the meaning of the word. But here in differentiation, if you see, there are 2 words, differentiation. Okay. So if you Google it and find it out, you'll get it. Key differentiation is something which is connected with, if you're observing, so let us take an example. I mean, you can check it out on the Wikipedia if you want. Okay. So suppose this is y-axis. I mean, let's write it down. This is y-axis. This is, dear students, x-axis. I'm not taking a specific equation that is like y equals to mx, a straight line equation, or y equals to x square, or parabolic equation. A simple graph I'm drawing, something like this. Okay. Now, if you see, this is 100% true that this graph will be having a mathematical equation connected with it from which it has originated, or vice versa. So I'll say y is a function of x. Got it? So, if at any point, say at suppose this is something as this point is having the coordinate as suppose x naught and something as y naught. If I wanted to find how this curve is changing at this point, something I will say this, suppose if I take a point which is very near to it, although you are able to see that this arrow which I'm drawing is far away, but assume this to be very near and I am using a very like Superman zoom. Okay. So this will be a small change in y and this is a small change in x. Okay. Because these are crash course classes on AP physics. So that's why I'm going in a quick way. Okay. But nothing of the things have been skipped. You can check it out. If you want to practice more, you can take the notes. Okay. So we define something like this. The x which is near to this x naught is the gap between that is been named as dx, which is an infinite simile, which means a very small change in x. Okay, and same towards the y-axis will be dy, which is infinitesimally small change in y. So basically, let us come to the point. You will be given a curve, you will be given an equation y equals to x square, xn, sine x, trigonometric functions, exponential functions, logarithmic functions, a lot of things. Okay. So what you need to do is this, you will be having a set of formulas which you must remember and then find the answer. It's finished. The physical significance is simple. Differentiation means to find the rate change expression of a one physical quantity with respect to some other physical quantity. I repeat it. Suppose there is a ball and the ball you're playing with a ball and the ball is moving in one dimension. That is one dimensional motion. Okay. So if we need to find that how the position of the ball is changing with respect to the time, we'll be using differentiation. If you are having x as a function of time there, I mean, if you're having the curve, basically the trajectory with time of the ball. And if you need to find dy by dx, that is the slope at any point, we have studied in the maths. I mean, if you're having the maths calculus curriculum, so you'll find it. So we'll say here, dy by dx is basically defined as something as f dash x. It's a derivative. It's known as derivative. Derivative of y with respect to x. Okay. And it's also been named as y. Okay. Please note it down. Now directly I'll be providing you the set of formula list which you will have to remember, and then we'll practice the numericals. Okay. Now we'll see a list for the rules of differentiation. Okay. So let us start. Okay, my dear students, so these are the basic rules. Few of the rules are still remaining. We'll see in the next writing. Okay, so let us see one thing. If you are given a y equals to c as a constant, okay, y equals to c as a constant means something as y equals to 2, y equals to 1, y equals to 3, y equals to 4. So if you differentiate it, you'll get a result as 0. Yes, 0. Let's think logically in a physical significance manner. Let's try to understand this. So when we say y is constant, what does it mean? It means constant. It will be same when the time is 0. It will be same when the time is 1 second. It will be same when time is 2 seconds. So as the time proceeds, time progresses, time is always running. I mean, you know it, never stops. We take a stopwatch and do it, but it doesn't work. I mean, the practical is the time always flows. Okay, but whether time is flowing, and now if I mean something, suppose let us take an example of the ball. The ball is on the ground at the position say x equals to 13. X equals to 13 meter. At time zero, take a stopwatch. At time zero, it's at the same position. Time equals to 1 second, it is again at the same position. Time equals to 3 seconds, same. 4, same. 6, same. Infinite. I mean, you just wait and wait. It's at the same position. It's stuck. X equals to 13 meter. So we'll say this is constant position. So it's not changing. So there is no rate change defined. I can't define the change of X position or Y position with respect to the time. It's zero. Let's fast move towards the next. These are the expression you must always remember. Y equals to x raised to power n means dy by dx is equals to nx n minus 1. This is a formula. How it comes, there is a limit. There is a chapter in the calculus which is basically limits. If you want to understand the depth of this, please go for that. And now this course, basic AP physics course, this is not included, please. Okay. So now you have to solve this. I hope you have the answers. Anybody have sent? No one? So we'll say dy by dx is equal to minus 1 upon x squared. How it comes? Apply this formula nx and minus 1. So if I say y 1 upon x can also be written as x raised to power minus 1. So I'll say dy by dx is equals to minus 1 upon minus 1. That is minus 1 upon x squared. Okay, it's fine. Now if we say y equals to sin x, dy by dx goes forward cos x. Y equals to cos x is minus sin x. And y equals to tan x, you have to remember as sec square x. And y equals to sec x, you have to remember it as sec x tan x. Please remember these formulas. But two more are remaining. Let me write it here. So we have 8th number and a 9th number, and let's finish. So we have already studied this thing, isn't it? That when C comes, it overtakes all. Authoritative, demanding, something forcefully overtakes negative. So negative sign will always. You can remember as per your analogy, it's just a simple trick. So for here also 100% and derivative or differentiation, I will do the differentiation of y with respect to x. This is differentiation of y with respect to x. So what will come as this, that is minus of course. Okay, just note it down. We have the derivative for logarithmic functions also. Okay. Please note it down. These are very easy. I mean, you will say how to remember this. Is there any trick for this? There is no trick for this. I mean, it's itself it's a trick only. But you see how good looking these formulas are, isn't it? This one is easy. This is also easy. ln x down ex, same ex, happiest. This is happiest. No complications. Okay. So this AX, this is dy by dx, AX you have to keep in first and then log A base E. Okay. It's very easy. Please note it down. Then we'll practice some numericals. Okay. I hope you have noted it. Okay. Now I'll be giving you a big numerical. Then I'll be seeing your, YouTube thing that is that the thing going well? I think there are some issues to the students. The YouTube, the sound issues. Let's check. But first, let me write the numerical here. So I hope both Zoom and YouTube students will be just able to grasp the things. So we have the idea. Okay, directly let us solve the numerical question, please. Big. Please solve it. Solve this numerical. Till then, I will be. Let me check what's happening on YouTube. Okay. So there is no problem in the sound. Sounds are perfect. Okay. So let's start it. Let's go. So we'll say, yeah, I want the fast answers. I want the fast answers. I'll say dy by dx is equals to 1 4x cube. Fast answers. Yeah, minus 1 upon x squared. This. Now we have a challenge here. Which formula I have used here? You know y equals to xn. Dy by dx goes nx n minus 1. Very easy, isn't it? Easy, easy. Already thought this one. So we know x. Just hold on. We know this thing. Square root x or is can also be in the exponent form can be written as x raised to power half. So we can say when we convert this like and we have this y. So you can say y dy by dx from here will be what? N. This power is what, students? This is something as n. Isn't it? This is something as n. I will say this is half n x n minus 1. This goes half x minus half. So this is 1 upon root something like this. Use the form. But you are already having 2 in front, a numerical value. But is it here? Cool. No need to worry. So what you need to do is this. Okay. Then plus cos x c, we know, authoritative, minus sin x, minus 3, ex, same again. Boom. We have this answer. This is the right answer. Please note it down. After this, we'll be studying U V rule and U by V rule. What's this U V rule? Okay, we'll check. It's like a chain rule. We'll be understanding these questions via, these UV and U by V rule via numericals. I hope you're enjoying the section. So first is y u dot v. How to differentiate this? And next is y equals to u by v. How to differentiate this? So you have a big, great challenge. Are you following this? Let's take a numerical. It will be far much easy for us. So here we are having a numerical y equals to x ln x, and here we are having a numerical y equals to something as x upon x. And you've been asked dy by dx. Here also you've been asked dy by dx, derivative. Okay. So how to solve? Very easy. Understand why I changed. We have the set of formulas for this and for this, blah, 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 but I'll be not going through that. I'll be going through a very tricky way. Just remember this. So when I say dy by dx is required, what do? First time to make this king owns everything. So first chance is for this x as a king. To differentiate it, you will get 1. You know, n x n minus 1, 1x, 1 minus 1, 0, something raised to power 0 is what? Again 1, isn't it? So leave the next king, servant. X is a king, servant. So ln x is a servant, leave it. Now what do you do? Plus, very easy, you know, plus join. So plus was joined, this is combined. So it's something same thing, plus. And then again, now the term have to be reversed. I mean, so now x is a servant and ln x is a king. What are you going to do with this? Take the x now. You know ln x, 1 by x. So this is ln x plus 1. This is my dear students, y dash 1 plus ln x. This is the right answer. Was not this easy? Now I'll apply the same for this. See, we have a set of formulas, u by v and all those. But I always solve this numerical via this multiplication rule. So let's solve this. So what I'll say, okay, let us go for the basic way. In the next class, we'll check, maybe during some practice session, we'll check it out how to solve this via chain rule. Okay. So it's very easy for us. Please note it down if you have any query. I'm able to, see your queries coming. If it's any, please, send your queries. So what you do in division rule is again very easy. You can see this is u, this is v. So this is king. It's easy to remember this. It's easy to remember this. What's the reason? This is up, top, king, down, servant, king. I'll say sin x differentiated 1. Minus you have to use. For the multiplication, you have to use positive, that is plus. For this, you have to use minus. So I'll say for this, it will be x, reverse the rule. Who was in the past the king is now servant. Who is servant now? Maybe in the future, the servant will be king. So this is something as this will go forward. I mean, there is some change in this. You just not do minus. I mean, here you're doing plus, here you're keeping here the sign as what? Negative. You also have to divide the complete expression via sin x squared. I mean, v squared basically is. So you get the answer as 1 upon sin x minus x upon sin x. This is very random expression. This is your answer. No worries. Okay. Don't get disturbed when you get a big solution at the end. I mean, the answer at the end. Don't think, okay, it's not simplified. I'm not able to simplify it. So it's very complex. No, it's not complex. It's very interesting. Okay. Please note it down. Okay, so now I'm erasing this. Now, sometimes in the AP physics, so sometimes, and some other competitive exams, you have been asked double differentiate, triple differentiate. Okay. Basically, you'll get up to the double. Okay. So, how will you be solving those numericals? Double differentiation. Let's understand this via simple numerical. Okay. So we know y is equals to, let's say, suppose sin x. Differentiate it for the first time. So you'll say dy by dx gives you the answer as cos x. What's written there? Double differentiate. So you'll do what? Differentiate it for one more time. So it will be something as d2 by dx squared. This is cos x goes what? Minus sin x. Okay, nice. So this is the answer. Very easy. Let's move next fast. Okay, solve this for me, for yourself, please. Y is equals to x cubed. So please solve it. Double differentiate it. I'm not just asking you to differentiate it. Just double differentiate it. What's the answer? I think you have solved it very easily. So we'll say dy by dx, use the rule nx and minus 1, 3x square. So d2 by dx square goes for what? 6x. It's finished. Answer is this. See, when we practice something again and again, then only it works, isn't it? Okay. It's not just about the practicing the things. I mean, you suppose let us take the example of differentiation. You're having the differentiation. I mean, you're having a differentiation topic, and you're having the set of practice problems to practice. It's not about just practicing all those things. I mean, you also have to keep the distractions away. I mean, suppose you're doing differentiation in between, you are thinking something else. Don't do that. Be focused, and also be focused on the practice problems. Practice it again and again. Also, don't get distract easily. Okay. So you have to continually keep your focus, the concentration, your brain energy in one direction. Then it works. Then it works. So let's move next. After this, we'll be understanding a very excellent, a very interesting uh, topic, that is maximum and minimum. Okay. Now, dear students, please be very much focused. Viewers, now we'll understand maximum and minimum. Maximum. What is this maximize and what is this minimize? Let's start with a simple description. Suppose you are given a equation or a function y equals to fx. Suppose we're given an equation or a function y equals to fx. Now this equation or function can be anything. Y equals to mx straight line, y equals to x square parabolic, y equals to x cube, anything. Trigonometric, logarithmic, exponentials, anything. So I'm taking a random one. Okay. You can easily see this is a curve y as a function of x. This is x-axis. This is something as y-axis. So the topmost point is for it looks like mountains and the valleys, isn't it? This is the peak point of the mountain. This is the valley. I mean, you can say the bottommost or the bottom point. Okay. So now we'll check how to find maxima and the minima. Starting with the maximum. Your first task is this. Whenever the question comes and you have been asked to find this maxima, so what you will do, or minima, what you will do, whenever you get the question, just differentiate this. Okay, just differentiate. So once I differentiate this, I'll get something, the first derivative, that is f dash x. We'll get first derivative, that is f dash x. Okay. Now, once you get f dash x, this is your first step. In the next step, what you'll be doing, 0. Put this f dash x equals to 0. Very easy. It's very easy, not hard. So when you put this f dash x equals to 0, you'll get some certain values of x, x1, x2, say xn. I mean, it depends what is the power of the function, x power, because you know nx n minus 1, it depends on trigonometric, logarithmic functions, exponential functions, blah blah blah. Okay. So these are the values. Okay. Next is this. You have to double differentiate by dx square. So this is f double dash x. When you will double differentiate this equation, what you need to do is this. Now you will one by one, you will be, taking all these values starting from x1, x2, xn. You'll take the values like a crane, take the values, put in the function. So check the function. If the function is coming greater than 0, if or if you can say, if you put the value something x1, x2, blah blah blah. If the function is coming, say greater than 0, less than 0, these values, okay, or maybe 0. Let's take the third one, or maybe 0. I'm repeating the thing. You get a function y equals to x, f equals to x cube, x6, x7, x8, or something y equals to sine x, cos x, logarithmic x, blah blah. They're asking you to find maxima or they're asking you to find minima. The steps are common, no worries. First you will do differentiate it, keep it to 0, you'll get the values x1, x2, xn. Okay. Double differentiate it, you'll get an expression. Put these values one by one. Suppose for x1, it's coming greater than 0. For x2, it's this same expression. I mean, once differentiated, again differentiated, double differentiated, x1 greater than 0. For x2, it's coming less than 0. For x3, suppose the values are just 2 or 3. It depends on the main function. It's coming 0. So if it's greater than 0, let's understand. If it is greater than 0, what does that mean? It means the slope is changing positive. So dy by dx stands for the slope of the curve, slope at the curve at particular point. Remember, the first differentiation derivative dy by dx stands for slope at a particular point on the curve, slope at a particular point on the curve. Okay, slope at a particular point on the curve. So if the slope is changing in a positive way, slope is changing in a positive way, we say it's positive changing. No, it's positive. So you can see it's what? It's bottom. So you write here minimum. Now, if you see here, dy by dx, dy by dx, dy by dx. So at all these nearby points, you can see dy by dx, that is d2 by dx, that is dy by dx change. So if it's required for me to elaborate it, it's d by dx, dy by dx. So you can see this is just a simple change of y with respect to x, but this is the change of the slope. This d by dx change, I can write it something here. The change of the slope we are checking with x. So here the slope line is changing positively. So this is minimum because you can see it's positive. Here the slope line is changing negative. It's negative. So you will say it's what? It's maximum. Okay. When it's 0, nothing is happening. I mean, it's linear something. So you will say it's stable. I mean, you're understanding work by energy. There are equilibrium points. I mean, stable, neutral, unstable. What do you do, right? It's better if you write it here. Nothing. I mean, neutral or constant. Okay, very easy. So you'll say at all those x points, I mean, suppose at x1 it's coming greater than 0. So at x1, if it's coming greater than 0, x1 point is basically the x coordinate where which you will put in the curve and you will directly get the result as maximum. If at x2 you're getting less than 0, so you'll say x2 is the point. So which if you put in the curve, you'll get what? Minimum. Okay. Please note it down. So when we'll be solving a simple numerical, it will be far much clear to you. Okay. Please note it down. I hope, dear students, you have noted. Okay, so now I'll be solving a numerical based on the maximum minimum. So my dear students, viewers, please find the maximum and the minimum values of this function. Very easy, simple steps, no worries in that. So we'll say at first you will differentiate the function, the common step for both of the answers. So here is the solution for you. When I'm going to differentiate this, I'll get okay. Next step was what are you going to do? And this what you do is this now put it to 0. So when you put f dash x equals to 0, I think there was some error in the previous one. I'll check if there was some error in the previous generalized expression. I'll apologize for that thing. I'll rectify it. But for now, what you need to do is this: you get an expression for both of the answers. If you need to find, first of all, differentiate this for the first time. When you differentiate this, you get f dash x equals to 0. Okay. So once you get f dash x equals to 0, I mean, you have to put it this expression, which is basically f dash x equals to 0. Put it, you'll get 3x squared minus 6x. Solve it, you'll get 3. Take the common 3x, you'll get x minus 2 equals to 0. So you're having two values, x equals to 2. Okay. First step, differentiate, put 0, you get the values. So these are our x1 and x2. Okay. We got x1 and x2, keep it aside. So we have x1 and x2 in a box. So this is our precious box. We have enclosed this value in the box. Now let me erase this. Now, as per the generalized case, what are you going to do? You will differentiate this expression one more time. Okay. So f double dash x double differentiation, right? Or d2 pi by dx. This will be what? This is 6x. 6x. Now we'll check at x1 and x2 what this f double dash x values goes towards. It goes towards the positive region. It goes towards this 0. This positive region, this 0. This negative region. So for x1, if it checks, x1 is what? It's 0. 0, it goes directly as 0. I mean, it's neutral. Leave it. At x2, if we see x2 value is what? It's 2. It goes 6 into 2. Everyone knows it's 12. It's positive. So we'll say f double dash x at x2 point is greater than 0. Remember? Remember that? Greater than 0 was what? Greater than 0 means slope is going like this. So it's minimum. So at x2 we get a minima. At x2 it's minimum. Okay? At x2 it's minimum. So what do you do? Let me check. 0 doesn't give 0. So minimum value. So here I think there's an error in this question. We'll not get the maximum one. I'll check in the next session. So we have x equals to 2, which is f double dash x goes positive, which is basically a minimum value. Let's put this x into this and you get a y value, which is a minimum value. Okay. So let's check. Yeah, no worries, expression all right. If you see here, yeah, so one of the student have notified this. Just double differentiate this. Okay, you'll get what? 6x, this x. Oh, so when you solve it, you'll get, no need to solve it, you'll get this expression as, put the value into this. So for x0, you're getting it as negative because you have the -6 pending here. And for that, you're getting it as 6 positive. Okay, that's fine. So listen here carefully. 3x squared minus 6x. Thank you so much. One of the students have rectified this. So we'll say 6x is the differentiation of this, and this is minus 6x. So this x goes 1, and we have minus 6 as a constant, but 0, 0. So this is f double dash x. So when I'm putting x1 equals to 0 in this, I'll get the answer as minus 6. Minus 6 is basically negative. And when I'm going to put this value x equals to 2 into this, we'll get 12 minus 6 is positive, which is greater than 0. So this is negative, this is positive. Negative value is for the minima, and the positive value is for what? I mean, negative value is for what? We have started this. Negative goes for what? When the slope is changing negative. I mean, negative is from up to down. It's maximum value. And when the slope is basically positively changing from down to up, it's what? Down to up says what? From down to up. It's basically minimum value. Okay. So remember this. So for this, it's fine, it's minimum. And for x0, it's maximum. Okay, am I raising good? Let me simplify this. So for x0, we're having this y as, okay, maximum. For x2, already seen it was minimum, but we told positive. Positive is what? Minimum, but our value was coming, I mean, double differentiation was coming as 12, but after rectification via student, it's coming as 6. Still, it's positive. Positive slope means like this. It's increasing. So when it's delta, it's something as, it's minimum. Please put the values. So here we get it as minimum. Now our job is we need to directly put the values into the main expression. Okay. Put it now. Y max is how much? 0, 0, 6. Directly I'm writing the things. So 6 is the maximum value. Minimum if we check 2 cube, 2 square, 6, 8, 4, 6. Two. This is minimum. So we have the minimum value as 2. We have the maximum value as 6. Finish. And it suits. So the curve can be something at x, it's 6 and something minimum goes at 2. So y equals to, you can assume, you can take the assumptions, very simple it is. So for a curve, it will be something like this, where this top is, something like this. Top is at y equals to 6 and the bottom is at y equals to 2. It's easy, isn't it? Please note it down. Now students, after this, we'll be starting basic integration. Basic integration. Basic integration is completed and our one short class of this session, AP Physics 1, Chapter 1, Basic Mathematics is it's finished. Okay. Let me raise this. Now we'll see basic integration. See, whatever the topics today we studied, starting from, yes, trigonometries, then differentiation, and now basic integration. Practice numericals. I'll be providing you the sheets. Okay, check. Never before attending the next live sessions, please always go for description. Okay. Let's start with the basic integration. Here's some modification of the student. Yeah. Anybody is having the query, please. I'm reading this. Your comments, please send your comments if you want any changes in the session. Okay. Okay, my dear students. So in the next class, due to urgency in the there is emergency in the session. Some students wanted to complete in the next class. Okay. So my dear students, in the next class, okay, I'll be ending the class soon. So in the next class, we'll be understanding basic integration. Yeah. I'm ending it soon. Students, I'm ending it soon. Now you can please stop in the Zoom. Don't send the chat. So basic integration, I will be starting in the next class. Okay. So thank you so much, dear students, for attending this class. Please practice the numericals. I know it's not a calculus course, but you have to practice the numericals, okay, again and again, connected with trigonometric identities or trigonometric questions or differentiation. Then only you'll be able to solve the physics numericals. You know that when we'll be studying, in the future, kinematics, motion in 1D and 2D, you'll be having, it will be asked from you to find expression for acceleration from variable functions. Suppose x is a function of time, v is a function of time, velocity is a function of time. And suppose sometime we have velocity as a function of x. So we'll see how to find acceleration. For that, you need differentiation, basic maths. And if we go to the advanced level, advanced in the sense in the most important chapter, the main physics chapter, that is center of mass and rotation mechanics, you require the integration. Tell me, if you don't know the basic, your roots are not well grounded, how are you able to answer all those big level questions, advanced level questions? Okay. Okay, so bye bye everyone. Take care, be happy. We'll meet in the next class starting from this topic, that is basic integration. Please subscribe the channel. Okay, bye.